Hi students, in this video we are going to convert standard form of complex number into polar form of complex number. These are the four problems we have. We are going to solve each and every problem now. We will just take up the first problem now. Here z is equal to 2 plus 2 root 3i. In order to convert it into polar form, we need modulus of z and the principal argument, because polar form of the complex number is r into cos theta plus I sin theta, where r is the modulus of z. Hence we need to calculate this theta and then r value. R is nothing but our modulus. In order to find out it, what we do is just we are finding out what is real part of a complex number, that is 2. Imaginary part of complex number is 2 root 3. We need to calculate modulus of z. Modulus of z means the distance from origin to that point. Here we can use distance between 2 points formula that we learnt in coordinate system. So root over of, here it will come real part of z whole square plus imaginary part of whole square. So we get the modulus of z value, that is r value is equal to 4. Now we got this r value. Now we need to calculate this principal argument value. So we are going to calculate principal argument. Here if you observe it, real part of z is positive and imaginary part of the complex number is positive. Hence both of them are positive, means it lies in the first quadrant. It lies, and we know that principal argument means it must lie, the angle must lie between minus pi to plus pi. If you observe it in the first quadrant, the theta is less than 90 degrees. So we know that the principal argument when the complex number falls in the first quadrant is the angle theta itself. So we need to calculate it. We know that based on this diagram we can say this 2 comma 2 root 3 2 root 3. So here 2 root 3 will come, here 2 will come. If you calculate tan theta is equal to modulus of imaginary of complex, imaginary of z and real part of z, 2 root 3 divided by 2. If you can take it outside also, so you can take it this as 2 root 3 divided by 2, because modulus always gives positive value. 2 and 2 will get cancelled. We will get tan theta is equal to root 3. This root 3 can be written as tan pi by 3. Now tan theta is equal to tan pi by 3, means definitely theta value will be pi by 3. Here this angle itself is the principal argument, hence argument of z is pi by 3. Hence we can substitute those value. In place of r we can substitute 4, and in place of theta we are substituting pi by 3, and hence we converted this complex number into polar form. So in this problem what we do is just we are calculating modulus of z, that is equal to r, and then we are calculating tan theta based on the quadrant in which the complex number lies. We will use the different formula that we learned for principal argument. I hope you understand this first problem. Now we move on to second problem. In the second problem, the given complex number is z is equal to minus 2 plus 2 root 3i. First you know that we have to calculate modulus of z, that is equal to r, which is equal to real part of real part of complex number square plus imaginary part of complex number. Both of them are same only with some negative sign, hence the modulus value will be same, the calculation will be same. Now we calculated modulus of z, that is r. Next we need to calculate theta, that is principal argument. In order to calculate principal argument, we need to check where, in which quadrant the complex number lies. If you observe it, the real part is minus and imaginary part is plus, that is hence it lies in the second quadrant. The real part represents x-axis, imaginary part represents y-axis. Here x-axis is negative, y-axis positive, hence the number lies in the second quadrant. Number lies in the second quadrant means you know that the principal argument should be calculated pi minus theta, that we discussed in the previous video. So first we will calculate theta, and then the theta value should be subtracted from 180 degree. We know that tan theta is equal to modulus of imaginary part divided by real part. Here imaginary part is 2 root 3 and imaginary part is minus 2. We are just taking these values outside the modulus value. Modulus always produces positive value, hence 2 root 3 divided by plus 2, and 2 will get cancelled, root 3, hence tan theta is equal to root 3 mean we can write this root 3 as tan 60 degree. Hence when tan theta is equal to tan 60 degree, definitely theta value will be 60 degree. Since the complex number lies in the second quadrant, the principal argument can be calculated by pi minus theta. Hence pi minus this theta, which is equal to 2 by 3. Now we are substituting it in the polar form, so we get the final answer. I hope you understand this problem. Now we move on to next question. Here the next question is z is equal to minus 2 root 3i. It has to be converted into polar form, so we need to calculate modulus of z, which is equal to r, which gives us real part square plus imaginary part square. If you calculate it, the answer is 4. Next we need to calculate principal argument. In order to calculate principal argument, we need to find out where this complex number lies. If you observe it, real number is negative and imaginary value is negative, that is x coordinate value is negative, y coordinate value is negative. Hence theta, the number complex number, lies in the third quadrant. We know that principal argument should lie between minus pi to plus pi. If you calculate it from in the anti-clockwise direction, from a positive direction of x-axis, means the angle will be greater than 180 degree. That's why we are calculating the argument in the clockwise direction. Since it lies in the third quadrant, the argument of z formula is minus of pi minus theta. So first we will calculate theta, that has to be subtracted from 180 degree, and then we will multiply it by minus sign. So tan theta is equal to modulus of minus 2 root 3 divided by minus root 2. We know that modulus sign always produces positive, hence it produces 2 root 3, and in the denominator also it produces plus 2. 2 will get cancelled. We know that tan theta is equal to root 3 means this root 3 can be written as tan pi by 3, hence theta value is equal to pi by 3. But the complex number lies in the third quadrant, hence argument of z is equal to pi minus theta. In front of it we put minus sign. When we simplify it, we get the principal argument as minus 2 pi by 3. Hence it can be substituted in the polar form. Already we calculated r value as 4, theta value is equal to minus 2 pi by 3. That is what we substituted. We got the final answer. Now we move on to the final question, that is z is equal to 2 minus 2 root 3i. Again, as you know, in order to convert this into the polar form, we will calculate modulus z. Modulus z value is 4 here. Then we need to calculate principal argument. First, for that we need to check where this ordered pair lies. If you observe it, x coordinate value is positive, y coordinate value is negative, means it lies in the fourth quadrant. When the angle lies in the fourth quadrant, when the complex number lies in the fourth quadrant, the argument of complex number is minus theta. So we will calculate theta using this tan theta is equal to imaginary part of z divided by real part of z. And so if you observe it, imaginary part is minus 2 root 3, real part is 2, and modulus always produce positive outputs, hence it becomes 2 root 3 divided by 2. 2 will get cancelled, we will get root 3. This root 3 can be written as tan 60 degree, that is tan pi by 3. Hence tan theta is equal to tan pi by 3 means theta value is equal to pi by 3. As the complex number lies in the fourth quadrant, its argument formula is argument of z is equal to minus theta. We got theta is equal to 60 degree, hence argument of z is equal to minus theta here, minus pi by 3, and these values r value and theta value are substituted in the polar form. We get the final answer. I hope you understand how to convert the standard form of complex number into this polar form with all these examples. With this, I am completing the video. In the next video, we will see some more problems related to it. Thank you, students. Thanks for your cooperation.